This is part 2 of the scale factor videos. In this video, we're going to deal with area scale factors. Now, so far we've learned that scale factor, it helps you enlarge or reduce a shape, and that a linear scale factor is a one-dimensional change to the shape. So it's the perimeter or sides of the shape. And you can enlarge them by making the larger number on top, smaller number on bottom of the same similar side of the shapes, or you can reduce them by doing the small number on top and the larger number on bottom. When we're dealing with area, we're dealing with a two-dimensional change, so our scale factor is going to be squared, and I'll show you why. So if I can zoom in, here we have our area scale factor sheet. Okay, so the area scale factor, if we have a shape here, little rectangle 4x3, it has an area of 12 centimeters squared. If we do a linear change to it, a linear change of 2, we end up with a shape that is 8 centimeters by 6 centimeters. That's our linear change. 2 times 4 is 8, 2 times 3 is 6. That gives us 4 times the area. Okay, so a linear change of 2 creates an area change of 4. If we have a linear change of 3, then we have our side goes from 4 to 4 times 3, which is 12, and from 3 to 3 times 3, which is 9. And that gives us, when you split it down, an area change of 9. Now, when I say scale factor is squared, you should remember that for 2 to become 4, it has been times by itself. For 3 to become 9, it has been times by itself. So 4 would become what? So let me just write this down for you. That's the same as saying 2 times 2, which is 2 squared. 3 times 3, which is 3 squared. In this case, 4 times 4, which is 4 squared. So an area change creates a scale factor change from the linear to the square. So you will always have to find what the difference is between your two images in the linear and then square it to find the area change. Or the reverse if the question gives you the area change and asks for the linear. We'll be doing these sorts of questions in the classroom. So we'll be looking at past paper questions for these. But to give you a very brief idea, if I draw another shape, I'm going to keep them rectangular just because it's simpler to draw. If I draw another shape, here we go. Say it's simpler to draw and then fail. There we go. This one has sides 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6. I'm not going to put units in this time. Remember, in these previous ones, we were dealing with centimeters, so we'd be dealing with centimeters squared when we deal with our change. I tell a lie, that would not be on the scale factor. That would be on the total. And I haven't added up the totals, right? Okay. 12, 24. So that one's 48. centimetres squared, and this one 48, 96, 98, 108 centimetres squared. Right, so in this one, I've got a shape that's 8 by 6. If I wanted to do a shape with a, work out the area of another shape with a similar length side, I would have 8 times 6 is, shouldn't have done 8, 48. Yeah, I've just done it up there, haven't I? 48 centimetres squared. If I have a shape with a similar, with the area has been scaled up, so in area scale factor of 2 this time, then my scale factor is 2, my linear scale factor is 2, my area, I should say area with scale factor of 2, my area will be 2 squared. Times my area. So that's 4 times 48. And now I'm really wishing I had my calculator. 4 times 48, well, 4 times 50 is 200. This is 2 less, so 2 less would be 8 less. 200, so I got 192 centimetres squared. So a similar shape that's been scaled by a scale factor of 2 would give us an area of 2 squared, which is 192. Like I say, we'll look at the exam questions because they're never quite so straightforward. There's always text to interpret before you get on to the actual scale factor work that you need to do. If we've been given the area of the large one at 192 and told just one of the sides, we could work it backwards as long as we were told the side in both of our images. We could work it backwards to work out a missing side. Right, I'm sure I've just thoroughly confused you, so I will leave it at that, and as I say, discuss it in class.